So for number 5, we've got nitrogen trihydride. All right, so that's going to be NH3. And oxygen. Okay, is oxygen one of our special elements? Yes, it is. So it comes as O2. Okay, produces nitrogen. Is that one of our special elements? Okay, and dihydrogen oxide. In other words, water. Don't ever write it that way. It sounds silly. Okay. All right. So I've got to balance this thing out. I could probably start with nitrogen. I'm just looking at that and thinking that that might be a good place to start, except that that's probably going to mess up my oxygens. Okay. So got a bit of it. This is a tricky balance, this one for sure. I'm going to start with hydrogen, but I'm going to do this. I know that if I put a 2 here to balance the nitrogen, I'm going to get an odd number over here for oxygen. Okay, does everyone follow me there? Okay, so what I'm going to do is I'm going to start with a 4 here. I'm going to double the number I wanted to start with because I know that'll take care of my odd number. Okay, and I'm going to see where that goes. Sometimes you have to kind of go through a reaction once, see where it takes you before you kind of decide. All right, so that's going to give me how many hydrogen? 12. All right, so I got to go over here. What needs to go here? A 6. Okay. That's going to give me 6 oxygen. So I got to go back over here and put a 3. All right, and I've got 4 nitrogen here, so what needs to go here? Okay, that seemed to work. Agreed? All right. One thing you do need to watch for, okay, is if when you get done balancing something, you can reduce the numbers, reduce the numbers. Okay, in this case I can't because I can't reduce 3, right? But once in a while we pick a number that's too big when we start, and when we get done, you get like, let's say 2, 4, 2, 2 as your balancing numbers. Well, you can reduce that down to 1, 2, 1, 1. All right, so if you can reduce your balancing numbers, reduce them. It just means that you had the right idea, but you used too many numbers, okay, or too big a numbers. All right, does that sort of make sense? So sometimes you got to do a little math game, and that's kind of what that one came down to, is just kind of looking at the factors involved. On the next one here? Okay, O. Okay, so for O, I've got an ionic compound reacting with an ionic compound, producing 2 other, well, water there written ionically. It's not really an ionic compound, but it's written that way. That's a double replacement reaction. Okay, and now I need to balance everything. I've got OH on this side, I've got OH on that side. Right now it looks balanced, so I'll leave it. But I've got 2 hydrogens over here, but I've only got 1 hydrogen here in the water. So what do I need to put in front of water? A 2. Okay, I can't count this hydrogen, and that's the thing that sometimes confuses people. This hydrogen here didn't come from here. It came from here. All right, and that's the thing that's why I always say if you got OH on one side and you're going to get water on the other, write water as HOH. It's way easier to track where everything came from. All right, so I put the 2 there, and now I've got to bring a 2 over here to balance my hydroxides, which works out really well because it gives me the 2 potassiums I was going to need over here. All right, everybody with me there? Okay. Any other ones giving us trouble? Cameron? R, yep. Okay, are all of those ionic? All the compounds in there ionic? Yes, they are. Water is written HOH, okay? This is a double replacement reaction. In a double replacement reaction, you are sometimes going to produce water, okay? It's still a double replacement reaction. Okay, so I've got, the problem with this one here is that the ammonium, okay, starts here as a 1, but goes over here as a 3. All right, so I'm seeing that as kind of my highest number. All right, so I'm going to put a 3 here to balance my ammonium, my NH4. All right, that's going to make it work. But when I do that, it gives me how many OHs? 3. All right, so when I put a 3 here, that now gives me how many hydrogens? 3. Well, there's 3 over here, so that's good. All right, and I've got 1 phosphate and 1 phosphate. So we've got her 1, 3, 3, 1. Again, the trick with one of those, you've got that hydroxide going back and forth, okay, and you've got these polyatomic ions, and we have that real tendency to look at those little numbers and misinterpret what they mean, okay. This is one phosphate, okay, but we have a tendency to look at this number and go, no, there's 4 phosphates. There's only one phosphate. Phosphate is PO4, okay, so that can be kind of tricky. Okay, any other ones? All right. I'm going to talk quickly about what we're going to be moving on to next week, okay? And that's the predicting of the products. Okay? Being able to predict the products of a reaction means you're only seeing half of it, and that is you're only seeing the reactants. Now, we learned about the reaction types the other day. All of the reaction types start differently. Agreed? Okay? A synthesis reaction starts out with 2 elements. A decomposition reaction starts out with 1 compound. A single replacement reaction has an element and an ionic compound. Double replacement starts with 2 ionic compounds. And a combustion reaction starts with carbon and hydrogen reacting with oxygen. All of them look different. So we should be able to identify a reaction by only the reactants. Once we know what kind of reaction it is, it's pretty easy to take the pattern and figure out what should be on the other side. All right? So let's start out with kind of an easy one. Let's start out with, let's say this. So I'm only giving you the reactants. What kind of reaction is that? It's a decomposition reaction. It's only one reactant. The only thing it can do is break down. So it's going to break down into nitrogen, which is special, and hydrogen, which is also special. Okay? Did we just predict the products of the reaction? That wasn't so hard, was it? Okay. All we have to be able to do is identify the reaction type and then know what happens in that reaction. Now I have to balance though, right? I'm not finished. I've got 3 hydrogens over here and 2 over there. Lowest common multiple is? Okay, now we're good. All right, so again, we're going to go over this. It takes a little bit of practice, but let's try one like this. I got calcium reacting with lithium sulfide. Here. That's a single replacement reaction. Element reacting with an ionic compound. All right. My element, metal or non-metal? Okay, so it's a metal. And what's going to happen in this single replacement reaction? Right. We take the element that's here and we switch it out of the compound for whatever is like it in the compound. Since this is a metal, it's going to swap out the metal, and we're going to end up with this. Lithium by itself, and calcium with sulfur. Okay, now, this is an ionic compound, so what do I need to do with it? Drop and swap. Well, calcium's a 2+, sulfur's a 2-, so that's okay. It's 1-to-1. No, I could have listed calcium sulfide and then lithium. That's fine. Yeah. Okay. All right. Then I got to balance everything. So that'll take care of that. Okay. That's sort of making sense. So we have to be pretty familiar with our reaction types, but other than that, it's pretty straightforward. Okay. These ones, the single replacement, they tend to be the trickiest because there's the most things to watch for. You're going to have an ionic compound that you produce that you'll have to drop and swap. There's a possibility that if this was a non-metal, that you could have a non-metal showing up over here that's one of our special elements, and you'd have to remember to put its little special number with it, okay, because it would be by itself. So there's a lot more things to check with a single replacement reaction than there is with anything else. The easiest ones are combustion, because combustion always has the same products. What are the products always? Water and carbon dioxide, right? So that's the easy one. You don't even have to predict it. You just know what's going to happen in that. And in double replacement reactions, we always just swap the metals. Okay, so let's look at a double replacement reaction here. Okay, if I've got So I've got a double replacement reaction because I've got two ionic compounds reacting with each other. I have to produce two different ionic compounds. And the way to do that is to just swap the metals. Right? So that means that lithium's new partner is going to be sulfur, and hydrogen's new partner is going to be nitrogen. Okay, what do I have to do with both of those? Drop and swap. This is a -2, and that's a +1, so we're looking at Li2S. Okay, and this is a -3, and this is a +1, so we're looking at H3N. Okay, and then I balance the whole reaction. I need a 2 there, and a 3 there, and a 3 there, and a 2 there. Okay. Everybody okay with that? Okay. So that's kind of where we're headed. Okay. Nothing terribly difficult, but you will have to, or you will become very familiar with your reaction types as we go along on that. Okay. Where this gets tricky is if I give you the reaction in word form. Okay? If I give you the reaction in word form, then you've got to write the formulas correctly. Otherwise, you won't get the products correct, you won't get the balancing correct, and you end up getting like 1 out of 4, okay, on a question like that. So really, really important that we can translate names into formulas effectively. Like, let's say this. Okay, so I write it out in words. I say hydrogen fluoride reacts with sulfur. Predict the products. Okay, well, my first step is I got to write the reactants out. Hydrogen fluoride, HF, -1 +1. So that's how that one looks. Okay, and I'm adding that to sulfur. Anything I got to remember here? Yeah. It's an 8, yeah. Sulfur's an 8. See, that's one of those little details, right, that we got to remember. Okay. What kind of reaction is that? Single replacement. Okay. Who does sulfur replace? Fluoride. It's a nonmetal. It replaces the nonmetal. So I have hydrogen end up with sulfur, and fluorine ends up by itself. Remember I told you there's more things to check for in a single replacement reaction than any other kind. What do I need to do with H and S? Eddie? Okay, this is a special element, so I need a 2 there, and what do I have to do with this? Swap and drop. H2S. Sulfur's a -2, hydrogen's a +1. Okay, now I got to go back and balance the whole reaction, and I got an 8 in here. Okay, so I got to put an 8 here, I've got to put a 16 here, and an 8 over here. I'm going to have big numbers, okay, because I had something in there with a big number. How confident are we feeling being able to do that? That's about as hard and tricky as they get. It's not really hard, it's just tricky, okay? Because there's lots of little things to remember, lots of little details. So I guess my piece of advice to you on when you're doing these is take your time, okay? Especially if it's on a test. Take your time, make sure you're looking for all those little details. Okay, have a good weekend, but not too good. And if you go to the football game tonight, behave yourself.